And I'll explain a little bit more about that in a minute. Then, in addition to the content standards, the standards that say what students should know and be able to do, there are the standards for mathematical practice, which are descriptions of the sorts of ways in which students should be able to think and the ways in which they perform mathematical work. So the K8 standards are broken into what we call domains. Those of you who've worked with standards will be used to this idea of having, say, 4 strands that go all the way from kindergarten to 12th grade: number and operations, geometry, data, algebra and functions, something like that. For reasons I'll talk about in a little bit more later, we chose a different design element for the standards, which are these things called domains. So you can think of them as mini strands, if you like. They're just somewhat smaller, more fine-grained, but more importantly, they have a beginning and an end. They don't, most of them don't run from kindergarten to 12th grade. They take account of the progressive structure of mathematics, where there are certain points where you move on from one thing to the next, and indicate that in the design by having an ending point in 5th grade, for example, for the number and operations domains. When we sort of move on to the number system. And so this domain design was part of our effort to introduce coherence into the curriculum. And as I say, I'll say a little bit more about that later. But that's the basic structure. The top level heading in the K8 standards is something like number and operations in base 10, and that occurs in every grade level from kindergarten to 5th grade. Under those domain headings, there are clusters of standards. So that's what these, you probably can't, I'm not sure everybody can read this, but the bold-faced headings are clusters, represent and solve problems involving addition and subtraction, add and subtract with infinity, work with equal groups of objects to gain foundations for multiplication. And under each cluster heading, there is anywhere from 1 to, say, 4 or 5 standards. So the high school standards are organized in a similar hierarchical structure, but those top-level headings are what we call conceptual categories. So algebra, for example, in the Common Core is not a course called algebra. It's a category, it's a topic, if you like, in mathematics, and under that you'll have all the standards about that topic. But those standards could, depending on your course design, be spread out or interwoven in some way with other standards over any number of grade levels. Of course, there are 2 main designs for high school courses in this country: the traditional arrangement into Algebra 1, Geometry, Algebra 2, and then whatever comes after that, Trigonometry, Pre-Calculus. And then what is called the integrated approach, where you try and weave everything together into a coherent set of courses, which is just Math 1, Math 2, Math 3, but you're not devoting an entire year to a particular topic, but rather visiting multiple topics in each year. One of the reasons we chose the design the way we did was to allow states to choose which of those course sequences they would like to implement, or even to choose a different one to come up with something new. But there's another important reason for arranging high school mathematics into conceptual categories, which is to reveal the structure of the subject clearly. And then finally, as I mentioned, there are these standards for mathematical practice, which are descriptions of the sorts of abilities, ways of thinking, mathematical habits of mind that you want students to have. And these practice standards are rooted in a tradition that goes all the way back to the NCTM process standards, or the adding it up strands of mathematical proficiency. They're also rooted in research that's been done around habits of mind and ways of thinking. They're an attempt to be a bit more specific than some of those more general descriptions, partly because this is the first time that something like this has been written into state standards as standards. Well, probably not. There are probably states that have done that. I shouldn't say it's the first time, but now this is being done for everybody. And so we thought that we should try and give some mathematical specificity to them, since if you're making something a standard in a set of state standards, you're also requiring assessment to assess it, and it's a bit hard to do that with a generic description. The standards for mathematical practice are not intended to just be these sort of free-floating proficiencies. They're really intended to be anchored in the content, integrated into the content. And they're not something that you should think that every practice should be present in equal proportion all the time. They're not evenly spread out over the work that students do. On the left there's a diagram that groups them together into sort of 4 general areas which might be more suitable for, in elementary school, it's not so easy to make a distinction between look for and make use of structure and look for and express regularity and repeated reasoning. You might want to group those together into a sort of general understanding of generalization and seeing structure. So this diagram on the left is an attempt to give a grouping of the practice standards that might be useful for people applying them, especially at elementary grades. So the next thing I'd like to talk about, so that's sort of my very, very rapid overview of like what the standards look like. Are there any questions at this stage? Have I gone too fast? Do you have questions but are afraid to ask them? Yes, sorry, who? And those people coming in, you've come in at a suitable intermission that you could actually go and find yourselves a seat. Okay, no questions? Okay, let me now talk a little bit about the sort of design principles for the, next slide, about the design principles for the standards. And there are 3 important design principles that I want to talk about. The first is focus. The criticism of the US curriculum as being a mile wide and an inch deep was something we took seriously, and the criticism that's often raised that students seem to keep needing to revisit things they've learned in a previous year and the next year, that a lot of time is spent each year on review, was something we took seriously. And so we tried to design standards that gave teachers the time in any given grade level to attend to some key topics so that the students could move on and do whatever it was they were supposed to do in the next grade level, and you had some chance that you'd actually achieve what you were supposed to achieve in grade 3, for example. So focus doesn't mean reducing the total amount of mathematics that students learn, at least it means that a little bit maybe, but mostly what it means is fewer topics per grade level. And that means throwing things out in grade levels, and I'll point that out in the next slide. Those are some of the hard decisions we had to make. If you've been involved in writing standards before, you know how this has often worked in states, that some big group of committee of people gets together in a big room and sort of starts negotiating over what's going to go into the standards, and everybody has their pet topic, and you end up with a sort of record of that discussion, and it's hard for that process to make hard decisions. A design process where you sort of it's like handing off the design of a building to an architectural firm. The architectural firm interviews all the clients and says, you know, we want a beautiful big garden, and we want big wide corridors, and we want everybody should have a window office, and so on and so forth. And then it's the job of the architectural team to come up with something that accommodates as much as possible of what's wanted by the client, but it's never going to be possible to give them everything they want. And the design team has to also obey the laws of physics and gravity and so on in designing their building. So So that's a little bit like, I think, what we were doing, what the 3-person writing team was doing. We were taking submissions from the larger work team, we were taking commentary from the field and trying to design something.